In this video, we'll be going over populating next right pointer in each node. So you're given a perfect binary tree where all leaves are on the same level, and every parent has two children. The binary tree has the following definition. So we're given a node, we have a value, left and right subtree, and also the next node, which basically is the node to the right. So populate each next right pointer to point to its next right node. If there's no next right node, the next pointer should be set to null. Initially, all next pointers are null. So the follow-up is we may only use constant space, and any of the recursive call stack memories will be not counted as extra space. So in our first example, we have a perfect binary tree, and we're trying to connect each node to its next node. So currently, the 1 does not have a next node, so it's set to null. And then 2 has a next node of 3, so we set 2.next to 3. And in order to connect these two nodes, we can just connect them in a parent node. When we're currently at 1 here, we can connect 2 and 3 together since we have access to both nodes. And then the next level, we can connect 4 and 5, 5 and 6, and 6 to 7. And 2 can connect 4 and 5 easily. But in order to connect 5 and 6, we need to have access to this node here at 3. Since we have already connected 2.next to is equal to 3 in the previous node, this means we can easily access this node here, and we can connect 5 and 6. Let's go over the thought process. We will be implementing a level order traversal. For each of the node X, we will first want to connect the next pointers of its children nodes. So this can be done by setting x.left.next to x.right. So this is similar to the case if we're currently at node X here at 2, we could connect the left child to the right child. Now we will also need to handle the case where the right child of X needed to be connected to the left child of x.next. So we're currently at 2 and x.next is here. We need to connect 5 and 6. So we can set x.right.next to x.next.left. x.next is 3, x.next.left is 6. Let's go over the pseudocode. So let's validate the input parameter. If roots is null, we can just return roots since we don't need to connect anything. So I'm going to create a variable node to keep track of our current starting position at each level. So while node.left, this is initially going to be roots. Initially roots. So while node.left is not null, this means we still have children nodes to connect together. So we're going to create two variables. First, we're going to create a variable left to keep track of the leftmost node on the next level. So set this to node.left. Since we're going level by level, we need to go down to the leftmost node later. And then we can create a variable x, our current node, at the current level. Then we're going to have while x is not null. Then we want to connect the children's node first. Let's first connect set x.left.next to x.right. And then if x.next is not null, this means we need to connect these two nodes here. We can set x.right.next to x.next.left. Then we want to move on to the next node to the right. So I'm going to set x to x.next. After we finish going through a single level, we want to go to the leftmost node on the next level, which is left here. So I'm going to set node to left. Then we can still return our roots. Now let's go over the time and space complexity. Time complexity is over n, where n is the number of nodes in the tree. We visit each node once. And our space complexity is of 1 because it's the iterative approach. Let's go over the code. So let's validate the input parameter. So if roots is null, we can just return null or just return roots. Then we're going to create a node to keep track of our current node the current leftmost node at each level, initially roots. So while node.left is not null, this means we still have children nodes to connect together. Then we're going to create two nodes. The first node is going to be the leftmost node on the next level, because we want to go down level by level and starting and moving from left to right at each level. And then we want to create a node to keep track of our current position at the current level. So while x is not equal to null, we want to connect the children nodes of x first. So we're going to set x.left.next to x.right. Then we want to check if x.next is not equal to null. Then we want to connect x.right.next to x.next.left. Then we want to move on to the next node at the current level. So x equals to x.next. Now after we finish this iteration, after we finish the current level, we want to move to the leftmost node on the next level. So I'm going to set node is equal to left. Then we can return the root node after. Let me know if any questions in the comment section below.